Welcome to another science exploration. Today, we're going to explore about how does a tidal power plant works and its energy conversion. It's a truly fascinating topic, so let's get right into it. In this explainer, we're going to quickly run through the power of tides, look at the specific parts of a tidal system, and then break down the step-by-step energy conversion. After that, we'll trace the complete energy flow, check out the types of tidal systems out there, and finally, wrap up with exactly why tidal energy matters so much.
All right, Section 1, the power of tides, gravity in action.
So picture this. Because the Earth is constantly rotating, and at the same time, gravity from the moon and the sun is relentlessly pulling at it, we literally have billions of gallons of ocean water on the move non-stop. It's wild. This constant push and pull creates a massive amount of kinetic energy, the energy of motion. And tidal energy, well, that's simply the electricity we manage to capture from this highly predictable, totally unstoppable natural force. And you see, this continuous sloshing around gives us two totally distinct opportunities to capture power. First up, we've got high tides, right? That's when the water level rises and just rushes toward the shore. But then we also have low tides, when all that massive volume of water recedes and flows right back out to sea. Both directions, in and out, offer this huge, rushing wave of kinetic energy that is just begging to be captured. Moving on to the next section, parts of the system, harnessing the ocean. Now, what's really cool here is that a tidal system actually functions a whole lot like a traditional hydroelectric dam. The big difference? It uses the ocean instead of a river. It basically breaks down into 5 main parts. First, the ocean water itself. That's our energy source. Second, we have a barrage, or essentially a dam, which controls the water flow. Third, all that moving water spins a turbine. Fourth, that turbine connects to a generator to actually produce the electricity. And finally, number 5, power lines carry all that freshly generated electricity straight to our communities. Next up, energy conversion steps, from tides to power. Okay, let's break this conversion down step by step. Step 1. During high tide, seawater rushes into a tidal basin and gets trapped by that barrage we just talked about. At this point, that stored water is holding a massive amount of potential energy. Step 2, as the tide inevitably changes, that water wants to rush back out to sea, and as it does, it blasts through and spins the turbine blades. Step 3, that intense spinning motion creates mechanical energy. And finally, Step 4, the generator takes over, seamlessly converting that mechanical motion directly into usable electricity. But wait, let's pause for a second here. We've got rotational motion happening inside the turbine, sure, but how does a spinning turbine actually generate electrical power? Like, what's the actual science behind turning mechanical energy into electricity? Well, the secret ingredient here is electromagnetic induction. So the spinning turbine is physically connected to the generator, right? Inside that generator, you have these massive magnets rapidly rotating near wire coils. It's kind of like the little dynamo that powers a bicycle light, but on an absolutely massive industrial scale. This interaction, spinning magnets around conductive wires, literally pulls an electrical current into existence. It's basically magic, but it's science. Let's zoom out a bit for our next section, complete energy flow, gravity to electricity. When you look at the big picture, it is a perfect, unbroken chain. Think about this. It literally starts all the way out in space with the moon's gravity. That gravity reaches out and pulls the ocean tides. Those tides create moving water here on Earth. That moving water spins our turbine. The turbine then rotates the generator, and boom, electricity is produced. We are, quite literally, powering our modern world using the gravitational pull of the cosmos. How cool is that? All right, next section, types of tidal systems, barrage versus stream. Now, to pull this off, engineers basically rely on 2 primary designs. First, we have the tidal barrage system. These things are massive. We're talking about a huge dam-like structure built entirely across a bay or a river mouth. It forces water through turbines on both the incoming and outgoing tides. On the flip side, we have the tidal stream generator. This one is a bit more surgical. It works a lot like an underwater wind turbine. It's completely submerged, and it gets spun purely by the natural, free-flowing currents of the ocean. And that brings us to our final section, why tidal energy matters, reliable and powerful. So why go to all this trouble to build underwater power plants? Well, it comes down to immense reliability and raw power. You see, unlike wind or sunlight, which, let's face it, can be pretty fickle, the tides are an absolute guarantee every single day. That makes managing the power grid an absolute breeze. But here is the ultimate advantage. Ocean water is over 800 times denser than air. Because of that incredible density, a single tidal turbine can generate vastly more power than a wind turbine of the exact same size. It's a massive step up in efficiency. At the end of the day, this whole process is all about transforming the natural, totally predictable rhythm of the ocean into the everyday power we need. We're converting raw tidal energy, turning it into mechanical energy, and finally snapping it into electrical energy. With our oceans covering roughly 70% of the entire planet, you really have to wonder, could the moon's gravity be the ultimate key to our clean energy future? If you find the video informative, please like the video. Thanks.